Good evening. My name is Brittany. Good evening. My name is Brittany, and I'm going to talk about my model. It's called the Natural Disaster Prediction Model. I'm going to give a brief introduction about natural disasters. Natural disasters are major adverse events resulting from natural processes of the earth. They may include tornadoes, hurricanes, earthquakes, volcanic eruptions, tsunamis, and other geologic processes. There are many types of natural disasters that may damage the environment and the lives of human beings. But some of these natural disasters are now predictable before their occurrence, but prevention of most of the natural phenomena is about next to impossible. But we can definitely reduce the quality of damage by an upcoming natural disaster. Natural disasters and how artificial intelligence can be applied to help predict them using the natural disaster prediction model. So to help reduce the loss of lives of people, property, displacement of families, awareness, and education plus preparedness has been carried out. In addition to this, they've come up with prediction and warning systems that are built to help understand, predict, and warn citizens about these natural disasters. With artificial intelligence, it has enabled this natural disaster prediction model for workers detect and prepare for these events such as earthquakes, tsunamis, volcanic eruptions, and many others. So, for example, with earthquakes, they have built artificial intelligence systems that can be trained with the help of seismic data to analyze the magnitude and patterns of these earthquakes, plus predict the location of the earthquakes and aftershocks. With hurricanes, they use artificial intelligence. They have used satellites to predict and monitor the path and intensity of these hurricanes plus tornadoes. For this natural disaster prediction model to work, I got the best data set I could use, which is the XV data set, also known as the satellite imagery data set. It's one of the largest publicly available data sets that contains mostly overhead imagery. This imagery can help us capture the complex scenes of the around the world. Applying computer vision to this overhead imagery has the potential to detect the emerging natural disasters. Using computer vision, we can argument. Argument means increase the value of something. Using computer vision, we can augment existing sensors. For example, the flood sensors can be used, which are used to measure moisture levels, seismic sensors, and vibration sensors, which are used to monitor earthquakes, are thereby increased in accuracy. And most importantly, they allow people to take precautions, stay safe, and prevent or reduce the number of deaths and injuries that can happen due to these natural disasters. The factors that I considered before selecting the above data set were the licensing of the data. There can be a number of restrictions on the access, use, and redistribution of the data. The license or terms of use under which the datasets are released has a significant but little understood impact on whether particular data can be used and by whom. Also, the unexpected costs that can hinder someone from accessing the data. Sometimes the data providers, including the government, may charge other users, even other government agencies, for access of this information as a way of compensating for creating and maintaining of the data set. Also, I looked at the authoritativeness of the data set. The proper authority over the data set can help us trust the data well and the results of any modeling and analysis made on the data used. Features in the data set that the prediction model is likely to use to help predict natural disasters. Use satellite imagery, which helps us to detect and identify regions that are impacted by a disaster for effective mobilization of relief efforts. In satellite imagery, there are also a number of features involved, which include labeled ground objects, which give specific information on the areas that are mostly partially hit by the particular disasters. We also have buildings, which include the intact and demolished buildings. With this, can be able to do immediate detection and mapping of these buildings, and we're also able to expedite rescue operations for the damaged buildings and also save lives. This is an example of a table showing how buildings were classified according to how bad damage they were. For not damaged, the buildings that are not damaged, they were undisturbed. There are no signs of water or no burn marks. The buildings that were minorly damaged, the building was partially burnt, volcanic floors nearby, and roof elements are either missing or had visible cracks. For buildings that were majorly damaged, they have partial wall or roof collapse, encroaching volcanic floor, or surrounded by water or mud. And those buildings that were heavily destroyed are either scorched, completely collapsed, partially or completely covered with water or mud. Now, I'm going to talk about the Bayesian theorem. The Bayesian theorem is also known as the Bayes rule. This theorem describes the probability of an event based on prior knowledge of conditions that might be related to that event. It is represented mathematically as probability of A over B, which is equal to probability of B over A, multiplied by the probability of A over the probability of B. Although Bayesian theorem is a powerful tool in the field of probability, Bayes theorem is also widely used in the field of machine learning. This Bayesian theorem in machine learning is very helpful in many applications, and its most important contribution in machine learning is developing classifier models such as Bayes optimal classifier and Naive Bayes. Statement formula of the Bayesian theorem is probability of A over B, which is equal to the probability of B over A, multiplied by the probability of A divided by the probability of B. Probability of A over B is the probability of an event A occurring given evidence B has already occurred. Probability of B over A means the probability of B occurring given evidence A has already been occurred. And probability of A is equal to probability of A occurring, and probability of B is equal to probability of B occurring. I'm also going to talk about the Naive Bayes. Naive Bayes is a probabilistic machine learning algorithm based on the Bayes theorem used in wide variety of classification tasks. It's one of the simplest and most effective classification algorithms, which helps to building the first machine learning models that can make good predictions. Although the algorithm is called naive, it's the fastest way to classify information. For example, about customers based on probability rather than relying on huge data sets, which are sometimes rarely available. This helps to reduce the load on the artificial intelligence system and keeps the output manageable and effective. Since naive Bayes classifiers do not need a model to be trained, they are easy and quick to implement. This allows for testing on real data without spending a lot of time and money on developing a model. When implemented, they are quick to make predictions. Saves a lot of time. And the types of naive Bayes model classifiers, we have the Gaussian classifier. This one assumes that features follow a normal distribution. We also have the multinomial classifier, which is used when the data is multinomially distributed and when a particular document classification problem belongs to a certain category. We also have the Bernoulli classifier, which works similar to the multinomial classifier, but the predictor variables are independent Boolean classifiers. Bayesian networks. A Bayesian network is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed acyclic graph. It's also called a Bayes network, belief network, decision network, or Bayesian model. Bayesian networks are probabilistic because these networks are built from probability distribution and also use probability theory, prediction, and anomaly detection. Real-world applications are probabilistic in nature. And to represent the relationship between multiple events, we need a Bayesian network. It can also be used in various tests such as prediction, time series prediction, anomaly detection, diagnostics, method insight, and decision making, and uncertainty. This is an example of a Bayesian network graph, and it's made up of nodes and arcs. For each node corresponds to the random variables, and a variable can be either discrete or continuous, and the arc or directed arrows represent the causal relationship or conditional probabilities between the random variables, as you can see in the image. So the difference between Bayesian theorem and naive Bayes is that the naive Bayes assumes conditional independence, whereas the Bayes theorem does not. In other words, this means that the relationship between all input features are independent. Difference between the naive Bayes and the Bayesian networks. And the naive Bayes, it assumes conditional independence, while Bayesian networks, it allows users to specify which attributes are, in fact, conditionally independent. And naive Bayes as a classifier, all its features are considered as attributes and are independent given the class. Whereas for Bayesian networks as a classifier, its features are selected based on scoring functions like Bayesian scoring function and minimal description length. Here references to my work. This natural hazard data, practical guide, Asian Development Bank, artificial intelligence for disaster risk reduction, and artificial intelligence and algorithms, KD nuggets, Russell, and the link to my data set is also available. And that's all I had for you today. Thank you for listening.